Straighten this bad boy up. All right, so here, if I can get both, if I zoom it out maybe. That's not bad. Yeah. Standard deviation, as Michael was going to point out, is roughly 20% of the states. There's only 50 states, and standard deviation is almost 20% of that. It's almost 10 out of 50. So that's a humongous standard deviation. Why is the standard deviation so large in this data set? The average number of states we've been to is about 16, right? With a standard deviation of a number of states of almost 10. On average, we are 10 states away from our average. Michael noticed something interesting too. Is anybody at average? Nobody's literally at average. The average is 16.
Well, it's because we have the big one.
Okay, so Kate's pointing out the fact that we've got some interesting stuff going on here with these 48, or the 44, and the 36, and the 28, and the 24. Maybe these guys are pulling a little bit.
The frequency is no longer, they're still large.
Good. My problem with this data set is the fact that it's so interesting, it's kind of hard to see what it actually looks like. I suggest we take a look at it, yes? Let's make a histogram. I didn't make you do this on your exam at all. But this is definitely the kind of thing you want to do. In general, in my opinion, this is my opinion, take it with a proper size grain of salt, I would take a look at the data before I even bother calculating the average, personally. Because the average might be a misleading statistic to use. Because of that high standard deviation and the few number of states, it might be meaningless. My opinion, just so you know. Let's take a look at it, right? Walk me through the steps of how to make a histogram of this data. And if you don't remember, this is a perfect time to remember. Or perfect time to relearn. Natalie, go.
Second stat plot.
Second, you got it. Stat plot. So second y equals button gets you to your stat plotter. Perfect. Yep, we're going to pick number 1 there. Plot number 1. Let's turn it on. Now you got to go down and select the histogram.
And change your frequency.
And this is the only thing, this is what Kate mentioned earlier when she was trying to graph her plot earlier. She wasn't changing the frequency to L2. Because we have our data in L1 and L2, you have to tell the TI that your data is in L1 with frequencies in L2. Does that make sense? It's just like when you do one of our stats. When you guys did one of our stats, you type one of our stats L1, comma L2.
How'd you get to this?
Second y equals. We're going to scroll down. Second L2. See a second y equals, Sherry? There you go. Okay, so far? So now she's set up. Now that you're all set up here, I think it's time to take a look at this thing. What's the easiest way to get a look at this thing?
Zoom 9.
Zoom 9. You guys got it. Zoom 9. Okay. Well, that does not look like a bell curve to me. That does not look bellish at all. Looks exponential, if anything. May I finagle a little bit?
Yeah.
I like finagling. Finagling's fun because it lets you kind of get in there and kind of just mess and see if there's a bell curve hidden somewhere. I'm guessing no. How do I finagle?
Window.
Window it is. Okay. My min is at 6. My max is at 50. I'm going to change it to 0 and 50 if it's okay with you guys.
Sure.
Just because that's the number of states we've got. Now, technically speaking, I should maybe go to 50 to 52 or 53, but don't worry about that because we didn't have anybody up there. Let's change the scaling to 5. What this will do is it'll have a bar for 0 to 5, and then a bar from 5 to 10, and then a bar from 10 to 15. It's a little more logical breakup than 6.3 states. That seems kind of silly. And if you finagle like this, what do you then press?
Graph.
You don't press Zoom 9 again, just press graph. All right. Not a bell curve. Still, even, maybe a little bit worse. Now you can keep finagling if you want to. By all means, finagle away. You can change your scales down to 4 if you want, just to see. Still not a bell curve. I mean, you've got a tail now. A tail beginning to grow out here on the side, but I sure wouldn't call that a bell curve. You can change it down to 2 if you want to. We're getting a little ridiculous now. Okay? But really, no matter how you work this data, and this is just so you know, this is always how it happens. This will not be bell-shaped data. We don't have a bell, we don't have an average that we kind of hover around. As a matter of fact, let me bob back out again. I'm going to change that back to a scale of 5.
Try Zoom Fit.
I hate Zoom Fit. You know that, Harrison. So here's 0, 5, 10, 15. 16, our average, is right here. Now, when it's grouped like this, you can't tell that 0 people are at 16. But you sure can tell that there's an interesting something going on over here and also something interesting going on over here. But those are so far away from average that the average doesn't capture them.
I think it's great skew.
You think it's great skewness, I agree. I think it's great skewness as well. And I wouldn't have you calculate Pearson's for this, especially on an exam, but in general, because you can look at that and go, oh my God, it's skewed. You know, you look at that and say it's skewed. So the question becomes, here's a question I have for us. I'm going to raise this up and leave it on the screen. The question is, it seems like our tools of center and variation around the center which are very, very lovely topics and very, very useful in lots of applications, it appears as though those two ideas are falling short with this data set. And this is the beautiful thing, because sometimes they do fall short. Sometimes they work great. Sometimes you get bell-shaped data. In this class, we'll talk about why and when and how often you do get bell-shaped data, and then something like this happens, or you don't. So what can you use instead? Well, go back to one of our stats again. I want to take a look at some stuff that's in there. So quit out of here. Back to one bar stats. Let's let this up. Second enter, one bar stat. Make sure you do L1, L2. Yes. Let's let that over here. Make sure you do an L1 and L2 on your one bar stats, otherwise you're going to get silliness.
Yeah, I forgot that.
It's easy to do, and then you get your numbers, you're like, that's not right.
Yeah, and I was like,
That's not right. Yeah. In general, when you forget to do L1 and L2, your standard deviations are exaggerated greatly, especially with that, I mean, on your test, there were like 5,000 baby weights in that sample.
yeah.
But if you don't do it, it says there's 10. You know that's not right. So hopefully you catch things like that. So right now there are 24 of you, yay, definitely. Got each of you to vote. We're going to ignore basically this entire screen. Scroll down, friends. Scroll down a little bit if you would. Okay. Now, if I may on the board, I am going to put these in order real quick. I'm going to put them in numerical order because I want to find the median how we used to find the median. So if you would just bear with me for a second, the 28 has to go here, the 36 and the 44, and there were 128, 136, and 144. I'll take these out of here. Now I think we're in order, right? Yeah, just by increasing. Okay, I want you to take a look at this guy right here. Those 5 numbers, what I want to start talking about today, and I want to continue talking about on Tuesday. Those 5 numbers right here are called the 5-number summary. The 5-number summary. Summary. That's pretty much the trade name for them. And 3 of the 5 of them, I think you have a pretty good idea what they are right away. Pick one of those 5 and tell me what it is and what it implies. Pick one. Kate, go.
Max, that's your highest number.
Your max value, 44, is your highest data point. Okay? It implies that it's the biggest. What percentile would that person be? To review from Tuesday. What percentile would that person be? 99th? Because how did you get that, Dawn?
Because you can't beat yourself.
You can't. So that person would be the 23 out of 24th percentile, because that person, Scott, 44 states, you exceeded 23 other people, so his percentage would be 23 24ths. That's not quite 99, is it? That's more like 96th percentile, I think. Right, something like that. But that's okay. The point is that it's the highest, because Scott exceeded everybody else, so he's in the 20, whatever 23 out of 24 is a percentage. I'm going to pretend it's 96%, I think it's close. 96th percentile. Boom, Scott. Thank you. Minimum is the lowest number in our data list. 6. There were 2 of them. What is the percentile rank of each of those, technically speaking? It's a 0. There is no percentile technically because they didn't exceed anybody. Does that make sense? So if we want to kind of break this down, I'm going to put this right here. It's okay with you guys. So the min for our data was 6, which we call the 0th percentile. Did we talk about this shortcut, this shorthand last time? This is kind of, I'll write it down words too. It's the 0th percentile. We talked about percentile ranking, I know, with Max. there's a shorthand for it. When you have a quotes, or when you have a big P sub number, that's just pretty much standard symbolism for a percentile rank. For our max of our data was 44, and that's the 96th percentile. In case you're later on at home not watching the video and trying to figure out why your notes say 96th percentile, remember that we exceeded 23 out of 24. That's where your .958 comes from, it sounds like from Jenny. That's the 96th percentile. Scott beat 96% of you. Okay, so that's 2 of the 5 we understand. Grab another one we understand. Median, Jenny. Tell me what the median is in our data set.
It's the middle of this data.
Good! Our median for our data set is 14, yes? Okay?
Could be 8 too.
Could be 8, 2. You're thinking mode.
Oh.
You're thinking mode, Michael. Thank you, sir. No, good. And the mode makes it even more tricky to use center because there are 2 modes, one of which is 14, one of which is 8. And that's why modes are kind of weird in that respect. And you see the mode on the graph we had? The modes were on the left side. That confuses the... It's very interesting how sometimes center falls on its face. What percentile is the median?
50.
Yes. Why? That's the average, which is sometimes the median. In this case, it's not. Why is the median the 50th percentile? Harrison?
It's the middle number.
Middle how? How is middle different than balance?
Because it's...
Half of it.
Do I have to bring JC back up here?
No, I think we need to see some cutting.
No, we don't have to see cutting. We can do this internally in our heads. When JC and I used to do our cutting dance up here, in this case, if we did the cutting, we'd be cutting off percentages all the way, right? So every time I cut one off the low end, we'd lose essentially 4% of the data. And then JC would cut one off the high end, there's 4% of the data. When we got down to the middle point, which would be between 12 and 13, we would have removed the bottom half and the top half of the data and grabbed the number directly between, wouldn't we? If it's the number directly between the bottom half of the data, what's the definition of percentile rank again? The percent of the data that your data point exceeds. Well, the median clearly leaves half the data below it. So the median has to be the 50th percentile. Let's just check. I won't embarrass JC again. I do it, it seems like I do it every day, and I apologize. So here is 14. See if you can see why. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Right? So 12, 13, and 14 are in here. That's why 14 is in here. Because both 12 and 13 have a numerical value of 14. Now please understand, when I say 12 and 13, I mean in order, the 12 and 13 spots have a numerical value of 14 states. So your median is right there. Your median is right there. Let's just spell the whole word out. There we go. And let me swing the camera over so we can see this. I want to see the computer. That's not bad. Okay. Okay, we now know what 3 of those 5 numbers mean. Yes? Yes. What are the other 2? Q1 and Q3. Absolutely.
There's a median of, like Q1's the median of the first half of the data.
The median of the first half. So Skylar's looking at 8.5. Skylar, I don't see an 8.5 up there anywhere.
So you go halfway.
Help me out, Heather.
Go
Go.
halfway between the median.
So Heather's saying between 8 and 9 is 8.5. Let's just do a quick little measurement here. So this is where Q1 lives. Right? That's where Q1 lives. Let's see if we can see any kind of significance why Q1 would be at 8.5. Remember how many data points we have in total in this data set? 24. When we found the median, we chopped that into the bottom 12 and the upper 12. Yes? Bottom 12, upper 12. What's interesting about that is the bottom 12 can then be split in half again and have 6 and 6. Now, I know some of you are looking at that and going, that's not 6, that's 5. 1, 2, 3, 4, 5. But remember, one of those guys, one of those 14s is in the bottom 12. There's 3 14s. Good, that makes sense, Megan? So if you take the bottom half of the data and split it in half again, not by balance point, Dawn, not by balance, but just by location, you construct what is Q1, which is also the 25th percentile. Thank you. It's called the first quartile. Q1 in language is called the first or lower quartile. or lower quartile. And all it is it's the 25th percentile. For us, it's 8.5. Does the fact that it's 8.5 bother anybody? It's the same way our median sometimes is one of our data points. Sometimes our median comes up to be a 0.5 because it's between two other data points or something else. Can you see why Q3 is 21? Let's find 21. I don't see 21, but conveniently, it's right between the 19 and the 23, isn't it? 21. Let's make sure we can convince ourselves why it should be 21. There's 12 data points on top, right? 1, 2, 3, 4, 5, 6. Those are the top 6. Top 6 data points. Bottom 6 of the top half, which seems kind of weird to say, but that would be like the just above median 25%. That's a terrible thing. I didn't just say that. 25% of your data is right here. 25% of your data is right here. The next 25% is right here, and the final 25% is over here. So if you count down, 1, 2, 3, 4, and then you're like, where are the other 2? Well, they're right there, 5 and 6. The other 2 14ths that weren't in the low part. So, Q3, what do you think? What are we going to call it? Oh, good. It's the 75th percentile. I love the fact that you're tying it back to that. That makes me very happy. What else is it?
21.
Oh, it's 21, absolutely numerically. Well, what should we call it if we don't want to call it the 75th percentile?
The upper quartile.
Good! The upper or third quartile. I love that, Jamie. Thank you. Love it. That's what he is. Wait a minute, time out. We just went from Q1 to Q3.
Because Q2 is the median.
Thank you, Megan, because Q2 is the median, but nobody actually calls it that anymore.
They just call it median.
They just call it the median, because median is one of those words that we've grown to love because we use it so much, and it becomes part of the vernacular, whereas Q1 and Q3 don't. I mean, this is probably the first time you guys have talked about. How many of you have heard of the quartiles before? Yeah, exactly, like 1/5 of the class. But how many of you have heard of the median before you came in here? You see, exactly. So Q1 and Q3, the quartiles are less well known because they subdivide the data set down even further than the half does. And there are other aisles. There are octals. There are quintiles. The government loves its quintiles. So quartiles divide up the data set into 4 pieces. Quintiles divide it up into, as you might have guessed, 5. There are also deciles, which would divide it up into 10. Okay? I don't want to, inundate you with all those different aisles. I want to focus on the quartiles because these are the most common, number one. And if you understand and can tear apart quartiles, then you can deal with any other kind of aisle that comes along. So what I'll do is I'm going to save this data. And we're going to revisit this because there's some cool stuff going on with this data set that is not super indicative by just looking at it this way. There's a really, really freaking cool way of graphically looking at this data besides a histogram. And we'll play with that on, I don't know if we have time to do it in 4 minutes. I don't want to rush to get it done. So we'll play with that on Tuesday when I see you again. So for Tuesday, what are you doing? Do your class. Make sure you get that bad boy knocked out. Kate, go.
So your median is always 50th percentile.
Always.
And Q1 is already Q3. But is the min always the 0th percentile?
By the definition of the percent of those you exceed, it has to be. Because there is nothing smaller.
And the real one I'm asking is your max always that
Nope.
much is
Imagine if there were 100 people in this room, and I visited all 50 states. I'm the 99th percentile because I beat 99
all the
people.
way to be 99.
It depends. If there are 2, this is where it gets weird. If you only have 2 people in the room, the max is 50th percentile. It gets a little silly. Now, what generally happens though, Kate, to answer your question a little more realistically, generally you have thousands, if not tens and hundreds of thousands of data points, and the highest percentile is like 99.999 or something along those. Is that fair? I wanted to give you an accurate answer, but at the same time not inundate you with a bunch of weird facts that will probably never happen anyway. Cool? Good stuff, sister.
I've just written down that.
Oh, good for you. Good for you. I just realized that I'm recording 18 inches away from the camera.